Hello guys, my name is Shivam Pandey and you are watching me on Discover and Uncover YouTube channel. And today we are starting with the unit number third of data structures in AKTU. And this unit is very important. It is basically a unit which covers your concepts of searching and sorting. So it is a type of unit where you have to code things and you have to just apply some logics into it, and you will not get much theory into it. You will have codes and you will have some algorithms and things like that. And it is very much important also for your gate preparation and also for your interviews and all, because in almost all the interviews the time complexities of these algorithms are asked. And carefully you have to study this unit because it is a very important aspect for your further studies and your gate preparation as well. So without wasting any time, we should begin with the unit. So basically, the very first thing that we have to get is that what is searching, right? So searching in C language is used to check the element is present in the given array or not. So it is quite obvious by the word search. When you think of searching something, then you get a picture in your mind that you are finding something. Yeah. So what we are doing here is that we have been given a set of data, or you can say that we have been given an array. So you have to search a particular element from that array. Let's suppose we have an array of number of elements type. The elements are 10, 20, 30, 40, and 50. And you are asked by the examiner that you have to find element 30. The question is that you have to find that 30 is present into the array or not. So what you have to do is that you have to make one logic, or you have to develop in code which finds 30 in the array and give you the exact position where 30 is placed in the array. Yeah, so now let us begin with the different types of searching techniques we use in this structures. And also we are not going to cover all the searching techniques because in the syllabus of AKTU very limited techniques are given, and I would say that only two techniques are there of searching, I guess. Yeah, so only two techniques are there: linear and binary search. And yeah, for sorting, we have been given different things. For sorting, you have to study, and there are almost 9 to 10 logics and techniques for that. But for searching, it is very easy, and you can get it easily in around half an hour. Right. So the very first thing of searching part is that we have to study about the linear search. So in a linear search, we can sequentially check each element of the list or array until the key element is found or the entire list has been traversed. So, what linear search is that we have to check each element of the list of array until the key element is found or the entire list has been traversed. So, what we are doing in the linear search is that we are we are checking the list of the array elements one by one, and when we will get the particular element that we want, then we will stop our the traverse, and we will just find the element, and we will return the index of that particular element. Right. So, in the linear search, if the element is found, the searching is successfully done. Otherwise, it is not executed. So it is very easy. For example, you have been given an array of elements 5, or you can say of length 5 also, and you are finding an element like 10 or 20 in that. So you will denote the key, or you can take the variable as key equal to 10, and you can traverse the variable, array from index 0 to fourth index. We will get you which will give you a count of 5 or 5 index of the array, and you have to find at each place whether 10 or 20 is present or not. If yes, then you have to return the index of that array, and if no, you have to just keep traversing, and at the end of the array you have to return that nothing is present, or you can return null also. So the second one is that we have to study about binary search. So it is a searching algorithm which is basically used to search an element in the sorted array. So the condition which we have in the binary search is that the array should be in a sorted manner. In the previous one, like in the linear search, there was no condition and it wasn't necessary that the array should be have to in a sorted manner. Here in a binary search, we have to keep the array in the sorted manner. So why is it so? Because in binary search, what we do is that we divide the array into two halves, two equal halves. I would say not equal halves by weight, but the indexes are divided into two equal parts. For example, if we have 10 elements in the array, then we divide into two parts as five onto the left and five onto the right. What we do is that we first take the element into the right part, and if we have got the element into the right part, then it is okay, and if not, then we do one thing, then we decrease the length, or we can say the middle value, which will be 5 here, then we reduce it by 1, like 4, and we again divide it into two parts, which is 2, 2. So what we do is that we again search the elements into two parts, that is 1 to 2 and from 2 to 5. If we get the element at at 2 to 5, then it is okay. If not, we again divide the element like 1 to 2 into two parts, like 1 and 2. And if the element is present at 2, then it is okay. And if not, we return 1. So this is the basic logic behind binary search. And it is good, but at the same time, it has to be like the code is quite not very much complex, but I would say that it is quite tough than linear search. And this code is made because it is like time complexity of this code is really very nice, and it saves times a lot of times, and it is very easy to implement, I would say. Yeah, so here we have been given the differentiation between the linear and the binary search. As I've already told, that linear search is applicable for unsorted as well as a sorted array, and binary search is only applicable to the sorted array. So this is the first point. In the second point, we can see in linear search we can say we can use for the small data set. Binary search is used for large data set. Yeah. So as I have said that in linear search you have to check the elements one by one, and you don't have any option to just skip this step. But in binary search, you can skip checking some elements in the array, and you can directly get your results by checking the other set of elements when you divide it into two halves. Yeah, so we have been given the binary search algorithm. So you can see that the step one contains find a mid and compare value with the middle element, say x. So what I have to do in the example is exactly the same which is written over here. So you have to calculate the mid. For example, if the array is of 10, the mid would be 5. If the array is of length 6, then the middle value would be 3. Correct? So this is the logic behind it, and things are easier to memorize and think here. Yeah, so if x is equal to y value, then it will return the index of the middle element, and if not, then what I have said is the same thing which is written over here. And I'm not going to repeat these things again. So I'm just skipping it, and I'm moving forward to the linear search code. So yeah, so the code is written over here, and the example, for example, we have taken this array which has 7 elements, and the zeroth element starts from 10th, and the last one is 4. I think so that this is not clearly visible. It is 11. If anyone has difficulty to say it, and it has a size of 7 that I have told you, and The code is now let us see what the code is about. Yeah. So, so basically, the first end is of the header file that you always use in C. So all the codes which I'm showing are in C language. If anyone have a confusion over it, and you have to just write the main body int main, and whenever you write int main, you have to return it by zero. If someone says that you can also ignore return zero, but it is logically correct and it is like a good code if you return zero it, and if you don't return zero then it is also fine, the code will run, but that is not ethically correct. Yeah, so for the variables we have taken two variables for int num. We have taken a variable num which will be a number that we have to search in the array, and a is the array in which we are storing the elements. For example, we here are choosing an array of size 5, and the five elements are here, as you can see, 1 2 3 4 5, and you have to printf and you have to write that enter a number you want to search in the array, and you have to scanf by just storing the value of that user input into a variable num, and and after that what you have to do that you have to run a loop from I equal to 0 to I equal to 4. Sorry, if you run that code for the times I less than 5, then what it becomes that it is less than 5 and less than 5 is 4. So it will run to 4, and it will run to 0 to 4, which is exactly 4 sorry 5 number of times, and the results would be same. If you use less than equal to 4 or less than 5, the results are same here. You can choose any one from these two, and I plus plus for just increasing the value of I after every for. So in the for loop, we have used an condition if, and this condition states that if array of I. So the I value will come from the for loop. For example, if a is for example, if a is 0, which means the index 0, the element at index 0 of array a, if equal to num, then the number is present in the array at percentage d location. So the location will be I, which would be from this array only. And if it is equal to the number which is required by the user, then we have to return the index where we have located the number. And if I double equal to 5, 20% is not present in the array. Huh. And if a situation occurs, if we are not getting the element which is entered by the user and we are getting nothing in the result, then we have to return that the number is not present in the array, and we have to just escape from this if statement, and we have to return 0, and this code is over. You have to see, you can see the output over here. Enter a number you want to search. You enter 6. As you can see from the array, 6 is not in the array, so it would return that 6 is not present in the array, right? And yeah, so it was the basic idea behind it. And here one more code is written. I don't know what the thing is here. Yeah, so they have used the concept of flag over here, and flag is also very important. And flag is basically, if you know about the chapter operating system, you know that semaphores are the, you know about the concept of semaphores, right? And semaphores are nothing but Boolean variables which have the value of 0 or 1. If they are 0, then they are denoting that they are closed or dead, and if they are 1, they are denoting that they are on and they can work, right? So this is the basic idea behind semaphores. And here also you can use the concept of flags. That totally depends on you. But the code that I have shared before, this one, it is very easy, and it is a beginner level code for linear search. There is no function, there is nothing. Only simple code. You can just implement in your exams in AKTU. But if you want to study higher for some higher perspective, or for gate or anything, then the things change there accordingly. But for now, it is very easy. Yeah. So here is the program of binary search. Right. So binary search, first line will be again your header file, which is hashtag include stdio.h, and the second line would be your int main, which is the main body by which you are in which you are writing the whole code. You have to like here the problem. I will not say that this is a problem, but you have to maintain several variables to store things. Now you will see that in the end there are several variables written over here. If I count them, then I see that one, two, three, four, five, six, and seven variables are there. So what the things are same here are this num and array. In the previous code also num and array was there. So it is the same thing in the previous code, and it is exactly the same here also. Now the things here change for I, low, high, mid, and end. What is mid? I have told you before also that mid is the middle value from the array in which you are searching things, and n, I would say n, I guess like n is the size of the array, so it would be the size of the array. For example, here the size is not fixed, I think so, and we are just taking the size of the array from the user only, and we are not denoting it by ourselves. So yeah, mid is that, and low and high. So low would be the, as I have said, low would be the leftmost point of the starting of the array, and high would be the endmost part, or the part or the index where the array is ending. And when we divide this into two halves, then we get the value mid. Correct. So size of the array is an n, and elements in the array we have to store it into the array, and we are storing it for sorry, uh, I missed one variable I. So basically what I is, that I is the iteration. I would say that we are only using it for iteration and not for anything else. So it is basically for just moving in the array from a zeroth place to the nth place of the array. So it is from I is equal to 0 to I less than n. Yeah, so same here. And enter the number you want to search. The user will enter a number, and you will store the number into num as we did before, exactly the same way. In the initial stage, what you have to do is that you have to denote the low equal to 0. For what we are doing it here, we know that the array starts from index 0. So we have to like take the low equal to 0 in the beginning, and if we see the index of high. So high would be the last value of the index, or the last value of the array. So we know that the array is of size n, and for the highest value, the size would be the highest value would be n minus 1. So low equal to 0 and high equal to n minus 1. Mid would be low plus high by 2, as we know this beforehand only. And this is the while condition, while low less than equal to high. What we are doing, that if low less than equal to high, if low is less than equal to high, so it is very obvious that it would be always equal to high, and this condition would be true always in the initial stages. And you will go into your if statement. If array mid less than number, if array mid, so the middle value if it is less than that of the number, then low would be equal to mid plus 1. So why we did this thing here? It is very easy if you see things clearly, and by using your brains. If low is less than equal to high, it is true, and if mid is less than equal to number. So if mid is less than number, for example, if the number is 3 and the middle value is 5, so the number is less than the mid value is greater than number. So now let us change this scenario, and we take the number as 7 and the middle value as 5. So what the thing becomes here is that the middle value 5 is less than that of the number 7. So what we are doing that we are at an index L low equal to 0. So we know that in the first half or the mid or up to the middle, the element which we are searching is not present. So what we do is that we change the value of the low and we move it to high sorry mid plus 1. You would say that why is it so, and is it necessary? Yeah, so it is very necessary. And the logic behind the logic behind doing it mid plus 1 is that it divides, or it just takes only that part of the array in which the probability of getting the element is there. So yeah, so it is the logic behind low equal to mid plus one, and else if array mid equal double equal to none, and if we get the element at the middle value only, then it is very easier for us, and we'll print one statement that percentage is found in array, and we will return the number and the index by which at which it is found. And if the thing is that we have not got the element, or you can say that we have not got the element into the right part of the mid value, so we will return so we will divide the so we will search in the left part with which is high equal to mid minus 1. So the high is at the last place. We have to bring it to the value, to the index which is left of the middlemost index of the array. So we return it as high equal to mid minus 1. So for example, if you have 10 elements, then high is at 9. You are returning it to mid minus 1, which is fourth element, right? So yeah, so it is the thing. And mid equal to low plus high by 2. Yeah, so we'll again update the mid, and we'll again search for the elements here. Correct. So if low equal to high, if it is the case that the low is greater than high, you can say that percentage d is not found in the array at location percentage d. This denotes that the element is not present in the array, by which the user is trying to find the element is not present, and you can return one statement that it is not present in the array, and you can do nothing for that. Yeah, so this is the code for binary search. The same logic is here also. You can see, yeah, same logic is there. While yeah, for finding mid equal to a and key for this, same things are there. There is nothing to worry much. The same things are there, and the only change I am seeing it here is we have used flag also. So you can use flag. There is no, but you can do it. But you can do this code without using flag also. That is totally fine, and it all depends on you. So if you ask me that what is the advantage of a flag, then I can say that it only returns, or it only checks the statement where, in the case where we have got the required search element, and it returns the index, or it returns the block of the code where we have got the element. So after which we are getting the other half of the chapter, which is sorting techniques. And I would say that sorting is also very big and a large part in it to cover, and it is also very critical to think upon and to execute upon. So there is time requirement for this, and I am concluding this lecture over here. And I would take the next class upon sorting techniques in data structures. So up till that, have a good day, study well, and have a great future ahead. Thank you.